Hello everyone. Today we are going to solve question number 97, interleaving strings on LeetCode. So what the problem states is that we are given three strings S1, S2 and S3, and what we need to find is whether S3 is found by an interleaving of S1 and S2, and they are also given the definition of interleaving two strings. An interleaving of two strings S and T is a configuration where S and T are divided into N and M substrings respectively, such that S is breaked into N parts and T is breaked into M parts, and this N minus M mod will be less than equal to 1. The interleaving is S1 plus T1, S2 plus T2, or T1 plus S1. So what does this mean is, this means nothing but first we have to take a chunk from S1, then a chunk from S2, then a chunk from S1, then again from S2, then again from S1. So one thing we can notice here is that it doesn't depend, so we don't need to worry about this n and m less than equal to 1, because this will always be true if we are taking the substrings from S1 and S2, because suppose we have taken some substring from S1, then from S2, then from S1, and so on. So when we count the total number of substrings taken from S1 and total number of substrings taken from S2, their difference will always be less than equal to 1. So we don't need to worry about that what are between the number of n and m. So looking at the example, we see here S1 is this string, S2 is this string, and we can form S3 using a substrings of S1 and S2 with the interleaving. In second example, we are given A, B, C, S1, and S2 is given D, B, C, A. So let's see, can we form S3 or not? So how can we form S3? Suppose we have given S3 as A, sorry, A, D, B, A, C, and C. So let's see how we'll form our S3. We take two pointers I, J, and another pointer which will be pointing at the start of this K. So first we need A. We look into S1 and S2. Can we get it from anywhere? Yes, we are getting it from this. So we will simply cross it and move I one step ahead, and K will also move one step ahead. Next we need A. So we see, is it present in S1 or S2? So it's present in S1. We cross it. Then our K moves here. Then we look for D. Is D present? Yes, D is present in J, and now J will move here. Next we need B, and one B is present here. So whenever we see that B is present in both strings S1 and S2, we need to move in S1 or S2. So this implies we'll form some kind of tree where we have to take from two options available. And looking at the constraints, which is here quite low, we can easily guess that it is nothing but a dynamic programming problem. So let's first run through this problem. So one B requirement is met here, and again two B's which will be matched here. then we need an A, but here we have only C and also C, so we cannot get A. So this means that no substring is possible, connecting which we get S3. And also there is one condition, that if size of S1 plus S2 size, if this is not equal to S3 size, this means that our string cannot be formed. So how can we solve this problem? So what we will do, we will take two pointers I, j. We have given S1, S2 and S3. One thing we notice is that if we take k here, the value of k will always be equal to I plus j. And initially we will be at 0 index, 0, 0, 0. And if we increase I, our k will increase by 1. And also if we increase j, then also we need to move one step forward in our S3. So how we will solve this problem is, we will, I'm writing a pseudocode here. So we'll make a utility function which will have S1, S2, S3, I and j, and k we can calculate at each step, which will nothing but I plus j. Now if we somehow reach k equals to S3 dot size, that means if we reach here, it means we have already covered this whole string, and this will mean that we have got our resultant answer. So if S3 dot size is equal to k, that means k reached beyond the index of S3, and we have got all the requirement strings, so we will return true. Now what we have two options, either we move in string S1 or we move in string S2. So we can move in string S1 only if I is less than S1 dot size and S1 at I equals S3 at k. Let's take example from here. AABCC, AABCC, S1, and S2 will be DBBCA, DBBCA, and our resultant string S3 is AADBBC, BCAC. So we will have I here, J here, K here, and we will only move in S1 if this and this position match, and similarly we can move in S2 if J and K match. So if this is true, we will take a local variable, so current, which will initially be false, then we will or the result we get by moving forward in this util S1, S2, S3, I plus 1 and j will not move. And similarly if j is less than S2 dot size and this, then we will or the result with calling j plus 1 and I, and finally we'll return current. And we, once we have the solution running, we can memorize this. So this is what the concept part looks like. Now let's move to the code. So in coding, what we need is, First we will check if s1 dot size plus s2 dot size is not equals s3 dot size. If the size do not match, we can never form a string. So we simply return false. Then we'll make a utility function and we'll pass s1 by reference. Similarly, we'll pass s2 and s3. We'll pass each of them by reference. Next, we need our two indexes to travel, int I and int j. And if for at each step we will first calculate what will be the value of k. So k will be nothing but I plus j. And if k reached s3 dot size, this means we have got our resultant string and we will return true. Next, we try possible values. So we will have current result as false. Then we'll check if I is less than s1 dot size and s1 at I equals s3 at k. This means that we have got a matching string, matching character, and we can move in s1. So we will OR the result returned by moving s1, s2, s3. Then we'll move I one step and they will remain same. Similarly, if j is less than s2 dot size and s2 at j equals s3 at k, we will OR the result with util s1, s2, s3. I will remain same and will move one step in j. And finally, we will return current. Let's see if it's running. Oh, we also need to call return util s1, s2, s3, and ing will start from 0 only. So our sample test cases are running, but we know that this will be giving us TLE as it is going, breaking into two steps at each step, two parts, so it will go exponential. So we will need to use the memoization technique here. We can simply use vector of vector, and at each step we will resize it, dp dot resize. So what are the values of I and j possible? So I can go maximum till 100, as you can see. The s1 dot length and s2 dot length can go only up to 100. So I can also go up to 100. To be on safer side, we will take 101. And similarly, j will also be 100. So we take 101. And the possible answers here are true and false. That means 0 and 1. So we will initialize our dp with a value that is not possible. So here I'm taking -1. Next, we simply need to memoize it. If dp at ij is not equals -1. What does this mean? This means that if it's not equal -1, I and j have been calculated previously and the answers must be stored in I and j index. So we'll simply return dp at ij, and after calculation we need to save also dp at ij equals current. So this is how we done memorization. If the value was calculated previously, simply return the same, store the current result and return the answer. So now see if it runs. So sample test cases are running fine. Let's try to submit it. So as you can see, it is giving the fastest solution possible. So let's see what will be the time complexity. So on observation, we see that what are the maximum possible values of I and j. So I can go from 0 till 100 and same can be the j. The maximum time complexity will be big of m into n, where m is size of s1 and n is size of s2, and same will be the space complexity, that is 101 cross 101. So 10 to the power 4 is the space complexity for this problem. So thank you. See you in the next video.